Welcome and thank you for joining us today. My name is Eric Basier. I'm Senior Director of Product Marketing here at Hammerspace. And today we're talking about a very relevant topic, this SSD supply crisis that the industry is facing, and kind of how to think about that and how to deal with it. And I'm joined by two speakers today. First, Simon Robinson, who is a Principal Analyst at Omdia. Simon, thank you for joining.
And thanks, Eric. Thanks for having me.
Yeah, looking forward to it. And also Molly Presley, the head of global marketing here at Hammerspace and host of the Data Unchained podcast. Molly, thank you for joining us this morning.
Yeah, you bet. Thanks for hosting us, Eric.
So this topic is just so relevant right now. I know it's a challenge and a problem that a lot of our customers are facing. And so we're going to be talking about this SSD supply crisis. We're going to be talking about kind of why it's happening, what we're seeing in the market in terms of the implications of this shortage, pricing, lead times, and things like that. Then we'll talk about why this is, an opportunity to rethink data architecture. Why does architecture matter more than ever? And then we'll close with 5 ways that Hammerspace can help. And so I'd like to just start by talking about just the crisis itself and some of the data from Omdia research. So Simon, let's start with you. Walk us through the situation. Kind of how did we get here? What are we seeing in the market? And what's some of the research saying from Omdia?
Yeah, thanks, Eric. And hey, everybody. So yeah, I mean, as you indicated, this is something of quite an unprecedented environment, I think, that we're in right now regarding this SSDs. SSDs, not just SSDs, actually. It's memory, it's DRAM, it's bleeding over to HDDs as well. And it's already building up to be a pretty dominant issue, not just across storage, but it's impacting the broader industry as well. And I think maybe the first thing to talk about is, well, this industry is famously cyclical. So why is this different? And what I think we have here is kind of a perfect storm. On the supply side, take that aspect first. We're coming off the back of what's actually been quite a difficult period for NAND flash. We've had a bit of a supply glut the last few years, but then this has quickly changed. So we've seen with the AI kind of revolution, we've seen soaring demand for GPUs, but also coming behind that is, well, where does that data live for a GPU? Well, it lives in super fast, high bandwidth memory, right? So HBM. So what we've seen is that we've seen memory originators change the focus from NAND flash to DRAM and to HBM. So kind of what we're seeing is supply tightening, right? Supply for flash, which is kind of the key element of SSD. We've got supply tightening just at the precise moment when demand for storage is exploding, right? And why is that? Well, I think that's kind of more obvious. AI is clearly moving mainstream. We're starting to embed, advanced inference through generative AI and all of these tools into our day-to-day behavior, and that's happening globally, right? It's supplementing, it's sometimes replacing traditional internet search, right? So it's not hard to see that the amount of data being generated is increasing massively. And remember, we're still only just getting started, right? These capabilities are becoming more and more sophisticated. We're moving from generative models to advanced reasoning models, agentic AI. We're starting to use not just text in these queries, but also images and video. So this is driving storage volumes even further. So specifically, kind of how we got here is that we saw in the latter half of last year, we saw the hyperscale AI providers essentially place some just extremely large orders for all forms of storage in the latter half of last year, but particularly NVMe flash, right? To the extent that SSD and HDD providers have sold out all of their entire 2026 allocations. Now, this is going to have some major impacts on pricing and availability of storage media across the entire industry. And this is something that we're tracking at Omdia to a fairly granular level across DRAM, flash, SSDs and HDDs. And prices are rising across the board. We're seeing NAND ASPs pretty much double year on year. And obviously bit volumes are increasing much, much less. So this is a price rise. And one really notable aspect is the price delta between, on a price per capacity basis, between enterprise SSDs and HDDs is widening massively, right? So SSD capacity is now around 13 times the cost of HDD capacity, or the price. That's a doubling of what it was 3 years ago. So, we're in something of a tight spot, right? The assumptions that we've been making around storage media pricing and availability for the past several years no longer apply, right? Prices are no longer always coming down. Supply is no longer plentiful, right? And maybe the final thing is that this doesn't look like it's going to be a temporary blip. We're looking at a constrained environment, certainly through the remainder of this year, but possibly well into 2027 and beyond. And this is ultimately an issue that's going to impact all organizations, if it isn't already. And as you can see here, our data suggests that organizational data growth rates are increasing, and data has been growing for decades, but that rate is increasing, and the biggest driver of that is AI. So the capacity is not going to be to absorb all of that new data is not going to be available at the price points that we are used to. So we're going to have to think of some alternative approaches. That's the situation in a nutshell as we see it today.
It's a perfect storm, and I think it's a great macro perspective. Molly, what are we hearing from our customers, our partners? What else are we kind of seeing at that level?
Yeah, definitely. This has become a hot topic, I think, with every customer and every partner almost overnight, seemingly just in the last couple of months. And some of the key things we're hearing, one, that quotes are being refreshed and need to be renewed frequently, like every couple of days, once a week, because it's so volatile that partners, customers don't really know what price they're going to end up paying. Even sometimes after they've booked a PO, the pricing can change. So, recommendations as far as if you're in the midst of an actual procurement and can get access to capacity to buy, keep an eye on pricing that is changing pretty frequently. We're also hearing a lot of conversations about not just the doom and gloom of the price increases and availability, but looking at the existing capacity in their organizations and figuring out maybe how can they take advantage of that. So we recently did a case study with Vanderbilt University, and while their reason for needing to look at how to use available capacity was a bit different, their procurement team said, hey, use all the capacity you have before we would go buy more. The net outcome of kind of how to architect it is very similar, that they had many storage systems from different vendors and different use cases, and had actually quite a bit of capacity if they could aggregate it across all those into a single namespace or into a single logical access area, that they wanted to use that capacity before they went and bought more. And so I'd encourage folks, if you haven't listened to that, there's a podcast, a case study and whatnot out on the Hammerspace website, to take a look at that. But really the idea is logically aggregate a couple hundred terabytes, maybe from your NetApp, a petabyte from your VAST, add some cloud capacity. And that's a good way that customers are starting to look at how to leverage what they already have before going out and trying to attack the procurement process in this market.
And we'll talk a little bit more about how Hammerspace can help with kind of the unique architecture. But I think so some really interesting kind of takeaways and insights so far. Massive pricing pressure, big increase on lead times, and it doesn't appear that this will be resolved in the short term. And I think Simon, when we were prepping for this, maybe you or somebody mentioned, I think there's a quote from Winston Churchill. I think it's attributed to him anyway. Never let a good crisis go to waste. Um, why, why does architecture matter now more than ever?
Yeah, I mean, I think because we're going to have to the assumptions that we've made about how we support and build a data infrastructure no longer kind of apply, right? And the in the past it was the easiest option was just to buy more capacity, and that option is now no longer as attractive. Even if you can get capacity, right, it's going to be much more expensive. So organizations are going to have to think much more carefully about, not only how they build and where they deploy capacity, but how they manage their data, right? So data architecture, storage architecture really matters. Perhaps, and it's always mattered, right? But I think perhaps it now it matters to a greater degree than it has in the past. Not all data is equal, right? Some data is more valuable than other data. The value of data changes over time. So the assumption that all data can just live on the same tier of storage, that assumption maybe no longer applies. So, I mean, Molly's already talked about some of the things that organizations can do broadly. We know that today storage is very, very fragmented, right? It lives in these silos: NAS, SAN, DAS, object, cloud. We over provision. We know that capacity is not fully utilized, but kind of that's the easiest way to do it, right? Because buying capacity is an onerous task. Provisioning that capacity, managing it is onerous. So you want to do it as few times as possible. So there's a lot of stranded capacity out there, and a lot of it is underutilized. I'd also kind of throw in tiering, right? That, again, this is a concept is not new, definitely not new. And I think over the last few years, we've moved away from tiering to more about, hey, let's just try and put everything on one tier, because that's the easiest way to do it. But I think when we think about the cost deltas between SSDs and HDDs, for example, that now looks much more attractive, right? And actually actively managing your data across these environments could be something that organizations might want to take another look at, right? Especially because there's now software available to do this in a much more kind of elegant way. And then maybe just the final thing to throw in is efficiency, right? So how do we use that capacity that we have as efficiently as possible? And, there's kind of some obvious things about, hey, let's use data deduplication, let's use compression, let's squeeze down that amount of data of storage that data is taking up. But also there are things like managing copies of data. It's incredible to me still how many copies of data that organizations have. And actually AI is a bit of a culprit in, further driving up that data bloat. Data copies are made for different reasons, moved into the cloud, on-prem. So how do we optimize and manage the copies of data that we have across the organization? So, they're some of the things I think organizations need to start thinking about, bringing together in a kind of a more holistic data strategy, if you like.
I like it. Molly, anything to add there quickly, or you want to shift into kind of the 5 ways we can help?
Yeah, I think that there's been a flurry of vendor commentaries about the best ways to manage this through this situation, and Simon highlighted a bunch of them. And one of the things I think, when you think about the idea of architecture matters is, this idea that it takes a crisis or something sometimes to do things new. I do see a lot of customers thinking about, okay, is now the time that I need to maybe architect or do something new than my path that I took in the past. For example, we work with one of the neo clouds that has had kind of a traditional GPUs next to high performance storage environment, and that was working just fine. Hammerspace has a technology called Tier Zero, which is a way to aggregate all the NVMe inside of a compute node into a shared storage pool to kind of augment the high performance storage. And in this case, they were like, you know what? We've already set up our Neo Cloud infrastructure. We're doing it the way we're doing it with tier one attached high performance storage. We're not going to break or change what's working. But this was a case where it forced them when they needed to add some more performance to that environment and couldn't get the SSDs needed to add the performance to their storage cluster in time for them to go back and look at, oh, okay, maybe we need to do something different. So I do think this is a case where there is a forcing function to invest in learning about some new technologies that will help get organizations through this procurement crunch, that we'll see folks starting to look at things a little bit differently than they were a year or two ago, where really the idea for storage was just put in some high performance storage and figure out how to get my GPUs optimized. It was all about the GPU. I think more elegant architecture around storage is going to become more common here in the next year or two as people think of efficient ways to use their capacity and their performance that's tied to that capacity.
Yeah, I agree. Well, let's get into we've kind of talked about the situation. We've talked about this supply constrained environment that is happening just at the time where some Omdia research and we know is saying that data growth is going to explode. Let's kind of shift into some practical ways that Hammerspace can help, and they're kind of summarized here on the slide. So I'm going to top line these, and then we'll go into each one in a little bit more depth. If you would like to learn more at any time, there's a link right in the center of your screen. There's actually two links. One will take you to a survival guide that we've created that talks a lot more about some practical ways that we can help and gives you a checklist to help you as an infrastructure leader work through this. There's also a link if you would like to set a meeting with us at the upcoming NVIDIA GTC conference. You can do that as well. So really the 5 ways that we're going to talk about that Hammerspace can help are using the flash capacity that's inside of your compute cluster. We'll talk about that first. We're going to talk about using disk-based storage or hard drive storage, leveraging that available capacity that you may have, and we'll give you some more examples of that. Using cloud storage. And, as Simon kind of mentioned, a lot of the hyperscalers have reserved a bunch of capacity. We work with these cloud providers, and they do have capacity available. So the idea here is not using cloud storage as kind of a one-way destination, but really using it as part of a dynamic hybrid cloud environment. And lastly, just reducing data copy sprawl and multi-site copy reduction. So let's go into each one of these. And again, if at any time, if you have questions, use the Q&A box that's in the lower left. And if you do want to learn more, use that link in the middle. So Molly, you had touched on this with what we call a tier 0 architecture. And we've actually worked with Simon and Omdia on this a little bit as we brought it to market. The premise here is that whether you have if you have a compute cluster, whether you have GPU servers or compute servers, there is local NVMe storage that's inside of that server. And typically it's not fully utilized. It's siloed. And so it's not used as a shared pool of storage. And Hammerspace allows you to turn that local storage into a shared pool of storage. And across the compute cluster, you might be able to activate this flash capacity that you already own that's maybe not being used today. Molly gave an example of a Neo Cloud. I'll share one other quick example where just last week we closed a deal with a quantitative investment firm in India. And just to give you a sense of that, they were using a compute cluster with high core count CPUs. And each one of their servers had about 160 terabyte of raw NVMe capacity. So just to give you a flavor, I mean, these capacity points are not small. And Molly, you touched on this, but this solution can be used both for adding capacity, but also for enhancing performance. Do you want to just talk a little bit more about our tier 0 solution?
I definitely would. And I'm glad you brought up the quant trading or high frequency trading environment, because that's not AI. That's traditional kind of enterprise HPC attached to CPUs. So, for those of you listening, this definitely is relevant to whatever your compute environment looks like and whatever your workload is that needs the capacity and performance. So I think that's always worth emphasizing because we do tend to talk about AI a lot, while in a lot of our customers, their workloads are very different, and this can help you too. So I'm glad you highlighted that. But on tier zero is really a multifaceted play. One, there's just high performance NVMe sitting there, potentially unused or very minimally used, that's already networked, cabled, deployed because the compute nodes are already up and running. So it's sitting there ready to go. And the ability to turn it on or enable it as part of your shared storage pool in your global namespace is really fast because it's a simple matter of software and configuration. So often you can turn that on in days. It's not the weeks or months you typically think of. Place an order, have some hardware kit arrive, configure it, install it, rack and stack and all that. So you can turn it on quickly, which helps to add some ability to be nimble in your organization. And then as you think about your workload, there's a few benefits here. It is capacity, as Eric touched on. When it's writing, so data is coming off the compute nodes onto the NVMe devices, it's local in the same compute node, so very low latency, really the fastest storage you could possibly get. So when you're writing data, it's super fast. Because it's sitting in a global namespace, we have the intelligence that once the data is written, we can do a variety of things. Protect it by mirroring it to another compute node, make sure that that data is immediately protected. Also, we can put objectives in place, which essentially are software policies that say, leave it on this compute node, immediately tier it to something else so I can free up that super high performance storage for other parts of my workload. So the data can be immediately visible to anyone connected to our global namespace, and it can be policied to move to where you need it to move. And that could be lower cost tiers, up to a cloud instance, whatever that might be. So on the read side, that's generally what it looks like. But I'm sorry, on the write side, when you're writing the data to the NVMe. On the read side, you can also be thinking about, well, how does this work when I maybe have 100 compute nodes and the data is not on the correct node for the GPUs or CPUs that are going to use it? And we could talk about this for hours. I won't, but we do have something called affinitization where we can proactively make sure the correct data on a read environment is local to the correct compute nodes. So think about orchestration of the workloads, the job schedulers, the job gets sent to a certain set of processors. We can use affinitization and data orchestration to make sure the data, when it's ready to be read, is in the right place. So tier zero has a lot of benefits. It's fast, it's available capacity. We can deploy it quickly because it's software. And we have great solutions both when data is being written and while it's being read.
That's great. I want to add two quick points that you reminded me of. One, so the way our tier zero architecture works, there's no agents, there's no client, and nothing that needs to be installed on the servers themselves. And that same quant trading firm that I mentioned, they were up and running in a day. So they had activated that storage capacity in about 1 day. And I did write down this quote. I did an interview with them yesterday. They were amazed with the simplicity of the deployment. So very cool solution. And I'll just add, this also is applicable in the cloud. So if you are deploying a compute cluster or a GPU cluster in one of the clouds, you can use the local NVMe that's in those compute instances and deploy a similar architecture in the cloud. Simon, I know we've worked with you on this a little bit as we brought it to market, gosh, well over a year ago now. Anything to add here from your perspective?
Yeah, I mean, I think I think you just hit on it on that last point. I think it's the elegance. I think the challenge with software-centric approaches to these sorts of problems is that they require a PhD in kind of managing the file system environment, and it requires implementing standing up an entirely new environment. I think the fact that this can be something that could be implemented relatively quickly, which you've just validated from the customer there, I think that's and really address not just a performance issue, sorry, not just a capacity issue, but a performance issue as well, right? Because that's often the challenge for organizations, is that they need to keep those GPUs fed with data as fast a rate as possible, right, to maximize the utilization of that very expensive resource. So I think this is a fabulous solution.
And I would add
let's
a
move
couple
on.
things
Go ahead,
there,
Mark.
Eric. Yeah, so you mentioned using Tier 0 in the cloud. I think an important point there to mention is likely, I mean, each cloud vendor is a bit different, but likely you're already paying for it. The NVMe storage, when you're buying a compute instance in the cloud, is included. It's just not generally how people think about using GPUs in the cloud or CPUs. I know in Oracle Cloud, that's a really interesting benefit, is it's just getting more for what you're already paying for. In addition to, as if any of you on this webinar have done a lot with cloud architecture, often the performance between storage instances and GPU instances isn't particularly fast because of networking and kind of the way the instances or shapes are being optimized. And in this case, again, you get the benefit of, even in the cloud, the NVMe are local to the GPU or CPU nodes, and you get super high performance that some of the architecture of the rest of the cloud matters a little bit less for at least this component. So we've seen some great customer successes with using this technology for their high performance compute in the cloud.
Excellent. Okay, let's move on and let's talk about using disk-based storage. And I think one of the interesting insights, Simon, you provided was, we've been on this trajectory where flash prices have kind of been coming closer and closer to hard drive prices. Well, we've now seen that reverse. And I think if I got this right, you're saying the expectation is flash dollar per gig pricing will be about 13x hard drive pricing. So
it already is.
Yeah. So this is a notion that's been around a long time. I think one of the things that is unique about what Hammerspace can offer here is a couple different things. Because Hammerspace is based on a parallel file system architecture, we're able to get performance out of flash as well as hard drive based storage. And perhaps more importantly is our ability to have both flash and hard drive storage, or both SSD and HDD storage, in one global namespace, and the ability to automate the tiering of those files or objects between flash and disk. So, Simon, you kind of talked about, we've been on this maybe path of no more tiers and putting everything on an all flash layer. And this presents an opportunity to kind of rethink that architecture. Maybe Molly, you first, anything to add here? And then we can actually talk about Vanderbilt next as an example of this, but anything to add on this point?
Yeah, I think there's a few things, and it kind of ties to a question that Roxanne Guggen put into the chat around, is this a new normal? We used to store everything on hard drives, and then there kind of jokingly was comments of hard drives are dead, just like tape is dead. However, neither really are. Like there's some industry cycles that occur here, and then there's some macro trends that are about the new normal. And I think what Roxanne's getting at, and she's a futurist who is kind of brilliant about predicting market insights. I've had the chance to talk to her a few times, so I kind of have an idea where she may be coming from on this. But I think that there's a few things to mention here, that this isn't very cyclical, that even if a SSD vendor could spin up, or a memory vendor could spin up a new fab today, whether they would or wouldn't is one question, but are they going to for the future? And there's a few dynamics here. It takes years to build a new fab. It costs billions of dollars. So the time to react to this, we definitely know that the crunch will last for a while. And as Simon talked about at the beginning, data is going to continue to grow. We know that inference is causing data growth, KV cache is causing data growth. Generated data out of AI is causing data growth. So I do think this is a new normal as far as the volume of data that's going to be created. And we're going to have to go back and look at what are the constraints that we're designing for, knowing that this kind of is a new normal. There's power constraints, we're talking about putting data centers in space to have heat dissipation. I've seen out in Saudi Arabia, they're building data centers underwater. Like there's a lot of things happening right now to help address environmentals as well as availability and cost. So when we're talking about the technology is available, I definitely think we will see a shift in just how things are for this new normal of a lot more data, a lot less power available, cooling being an issue, environmentals being an issue. And we'll definitely see things like hard drives probably having, kind of a reawakening or whatever term you want to use that while there's only a couple hard drive vendors still left, they're in a great situation right now that they have availability. They can, maybe spin up a little bit more capacity faster than building an entire new fab. But looking at the storage media and the right media for the job will definitely be something that is going to happen for a while. So to that point, looking at hard drives, if you can get access to hard drives or you have hard drives available and you've thought, they're not very fast. They don't really optimize my compute environment. There's a lot of things you can do. And again, looking at architecture to make your hard drives fast enough for these compute environments. One, they're still pretty darn fast. But two, if you look at your architecture and, or have some intelligent tiering or data orchestration to put the right data on SSDs, whether they're in the tier 0 compute node or some other SSD storage, those are options. But there's also software options. Use a parallel file system so the metadata is not being updated in the same data path as the data. So architecturally, get the busy metadata updates out of the data path so you can stream off of the hard drives instead of have, a workflow that is not optimized for hard drives. There's a lot of things on that side you can do. And you can look at, instead of using an HSM or a tiering type of, and I haven't said HSM in a long time, but the idea of you have reference points or stubs to files that sit somewhere else, you can now architect it where you're directly streaming off the hard drives instead of kind of rehydrating from one tier to the next tier to the next tier. So there's a lot of things that can be done here. And I do think we're going to see hard drives being used quite a bit for archive, even for warm storage. I'm certain there's a lot of hard drives sitting out in things like S3 and the cloud object stores. And so take a look at that and think about if your software architecture were done a little bit differently, are your hard drives fast enough to actually directly power your compute environment? Or, can you augment with less SSDs and use more HDDs to help get through this because of the way you architect your software?
Excellent. Simon, anything to add quickly on that?
Yeah, I think, to both of those points, I think one of the findings from our research is that not only is AI creating more data, but organizations now feel compelled because of the value, the potential future value of data, that they're now incentivized to keep that data for longer, right? So not only are we creating more data, we're now hanging on to that data for longer because we can use that in the future to train a model, gain insights, have much more interesting comparisons and so forth. And then there's a kind of a compliance and regulatory angle where organizations who are deploying AI are going to potentially have to demonstrate why their models came up with a certain data point. So that's going to drive the need for us to kind of hang on to more data for longer. And I think, to Molly's point, there's a lot of innovation now happening in the hard drive space around performance, around massively increasing capacity, and around tiering as well. So, the more things change in this industry, the more things stay the same in many ways.
Excellent. Well, let me kind of move on here, and we'll speed up these last few. Molly mentioned Vanderbilt University, their Advanced Computing Center, a little bit earlier, and I wanted to use it just to maybe bring together a couple of these things because it's a great example. What they did was basically aggregate capacity across their compute cluster, what we call a tier 0 architecture, a little bit of tier 1 storage on NVMe storage servers, and then their disk-based archive storage system. And so they aggregated about 10 petabytes of capacity. This gave them more flexibility to provide kind of high performance computing and storage services to the campus. And when they compared their blended storage costs of continuing to buy more all flash storage with some legacy HPC file systems compared to this architecture, not only did they gain more flexibility, but they reduced their storage costs by about 48%. So this is a great case study bringing together both a tier 0 architecture plus a tiered environment that includes SSD and HDD, all managed as one global namespace, all orchestrated by Hammerspace. So I think it's a great way to bring a couple of the concepts we've talked about together. Molly, anything to add here? I know you've touched on this a little bit already.
I think the only thing I'd like to add is I think a lot of folks might look at this and be thinking about their own environment, which may not look exactly like this. There was one question about can we tier across DRAM and NVMe flash? Another question about data sovereignty that absolutely you all are thinking about your own environment and your own requirements. There's few things I want to touch on there. Absolutely, we have done some testing and benchmarking, and there's some future development around the best ways to use DRAM as part of this, so even faster, and I think that is a piece that we'll be seeing more depending on your workflow, that having your DRAM part of this will be a part of this architecture. And then as you think about, well, this all sounds great if I'm just optimizing capacity, but I have other governance issues, GDPR, sovereignty, things like that I'm thinking about. So I just want to touch on that briefly, that within Hammerspace, we are aware of all the different storage types, locations, the performance attributes, as well as the location attributes of these environments. And as you're thinking about putting this all into one namespace, one data platform, we can set up rules that say, certain data is sovereign. It can't move outside of my country. Certain data has GDPR requirements, same types of things. So as you think about this, while you aggregate capacity, you don't have to think about the way you might have historically that this system, this NAS is for a certain type of data, and I just put that data there and I know that I'll meet my compliance because of that. In this type of environment, you're going to be, instead of being the physical storage system that's ensuring your compliance, it's software policies that will help you to ensure data is staying where it needs to stay as well.
Excellent. And we had one question on this slide, just clarifying the cost reduction. So Vanderbilt's total storage costs were reduced by 48%, and that's relative to if they would have continued to buy and deploy all flash systems with legacy HPC parallel file system technology. So they kind of went to this new architecture, and the effect was that it reduced their overall storage cost by 48%. So hopefully that clarifies that. Okay, and let's shift to the last couple, just in the interest of time. We've talked about using cloud storage a little bit. I think the point that I'd like to make here is just the way that Hammerspace works. This isn't using the cloud as kind of an endpoint or a one-way destination. It's actually, we can deploy Hammerspace as a global file system that spans multiple sites. It can also span clouds. So you can deploy Hammerspace in a hybrid cloud environment where it is a single global namespace that might span on-prem and in the cloud. And then we use that policy-based data placement, our data orchestration services, to move data between on-prem and cloud environments. And we have one customer I was going to mention here. They're a large kind of digital platform provider. And in their case, what they were trying to do was leverage GPU resources that in their case, it was in the Google Cloud platform for new AI initiative that they had. And a lot of their data was on-prem, again, on all flash NAS systems in their case. We were able to deploy this type of an architecture for them where they were able to dynamically move their data between the on-prem and cloud environments, so they could use cloud GPUs when they needed. They could use on-prem GPUs when they needed. We also help them reduce their underlying storage costs by moving from these kind of appliance-based NAS systems to more of a commodity object store as the back end data storage repository in their case. So again, kind of a new way to use cloud storage and leverage it. Again, Molly, anything to add there, or just kind of build on what I said?
No, I think you covered it well, that we definitely see an advantage through the situation of your data architectures being that it can be nimble and you can flex back and forth to the cloud, whether your organization has a cloud first or back to the data center strategy, wherever you are on that journey. This might be yet another reason why you might rethink that yet again. Where do you need to use compute? Also, where can you get access to the capacity and storage performance you need? And Hammerspace offers the flexibility for your workflows to very nimbly and dynamically move back and forth without having to reconfigure how the users and the applications are accessing the data. So it's very simple. Connect the applications and users to Hammerspace and our namespace. If the data and the workflow are moving to other locations, that's abstracted from the users and applications, so you're not constantly reconfiguring, connecting to a new storage silo or storage system. So it helps you have flexibility in a world where things are quite dynamic.
Excellent. And yeah, Simon, go ahead.
Yeah, sorry, I was just gonna add. I mean, I think this hybrid aspect is really interesting. We've talked about hybrid. The industry has talked about hybrid cloud for years, but it's only in the last little more recent times that I think this is becoming a reality. And there's a bunch of different things driving that. But AI is actually, if we kind of think about what's happening there, it's I think is one of the first truly hybrid workloads, right? The capabilities are often initially, at least, in the cloud, right? But whereas for most organizations, their data is on premises, right? So how do they manage that? How do they optimize that? That is going to require a solution that inherently allows them to move data efficiently back and forth. So I think this hybrid discussion is now pretty real, and this is really, really interesting capabilities here.
Excellent. Well, let's talk about the last point, and it's kind of, I would say, very much related to hybrid cloud, and this is about just reducing or multi-site copy reduction. And again, the one of our customers that I think about here, they're a biotechnology company. They were creating data on premise and primarily imaging data that was being written to a NAS system. And they were processing that data in the cloud. And for them, they had to do 4 manual data copies just to get the data from the on-prem NAS system up into a managed file service in the cloud. And so before Hammerspace, their experience was basically 4 copies. And with Hammerspace, with the global namespace technology that Molly talked about, we get rid of that. We have one single kind of golden data set and automate the movement of data, and we can place the data based on our data orchestration policies. So I think that has the effect of both reducing effective storage capacity, but also in a sense reducing business risk because you're working off of one golden data set. So that's kind of my top line on this. Molly, what would you add to that?
I think just going back to the idea of efficiency, of course, I'm sure everyone is looking at things like dedupe, compression, but this is an added piece you may not have been thinking about quite as much. How do I reduce globally the number of copies I have? Global dedupe, super cool. Idea of even having just less to dedupe and less copies is something that when you deploy a unified namespace across systems, you can accomplish. And because our namespace goes not just across our own technology as some vendors, but across your clouds, your different NAS, high performance storage, you can really effectively think about, do I actually have in my AI environment, a current environment where that take a copy, move it to another system, analyze it, move it to another system for processing. Now you have 3x the number of copies and capacity you need, because we can do it this way with pointers to a single copy instead of making multiple copies. That's a really effective way to first reduce the number of things before you then compress and dedupe. So a great thing to add to your thinking about efficiency of your storage systems.
Excellent. And yeah, Simon, any comments on this? So as we kind of start to wrap here.
I think you guys pretty much covered it. I mean, this is just one of those things where kind of this was sort of a nice to have in the past. This is almost becoming kind of essential, right? Because the cost of capacity is now going to really potentially impact the bottom line. So everything you can do, to squeeze out more efficiency is going to be really important.
Excellent. Well, let's kind of close on that before we take questions. And thank you everybody for staying around, and thank you Simon and Molly as well. If you would like to learn more, you can scan this QR code that's on the screen. This will take you to a landing page where you can get our survival guide. There's also a link there where you can actually just contact us and we will reach out to you. And what we like to do is a discovery session where we learn more about your environment. We learn more about kind of what it looks like now and where you may want to go. And then our team can come back with some specific suggestions for your environment based on all the things we've talked about today. So if you if you want to scan that, go ahead. Otherwise, let's take some of the questions that we got. I know that both Molly and Simon, you guys have answered some of these while we've been talking. So let's hit a couple that we have not hit yet live. First, there was a question of if this will be recorded and that if you want to share it with other people. So yes, we will share. This is being recorded. We'll share that after the live broadcast, and it's an easy link to share with your peers. Molly, I think you kind of talked a little bit about our perspective on, is this a normal cycle versus, or is this going to be a cyclical storage crunch versus like a new normal? Both Simon or Molly, do you want to add any more commentary on that? I like the phrasing of the question. Why is this not a tipping point? So any other perspective you'd like to share on that?
I think there's probably like a 2-hour conversation off the back of this one. I think AI, if AI plays out to be as impactful as we think it will be, and there are some cautions and things out there, but I think this is a step function change in the requirements of what an infrastructure needs to be, right? What a data infrastructure needs to be, and without kind of overstating it, I think it does change the game in terms of what you need from a data infrastructure, and I think it's going to put pressure on organizations that do have kind of the legacy siloed based approaches. So the pace is going to differ across different organizations, but as we move from scaling AI applications from kind of a POC into this next phase of deployment at scale, agentic at scale, the data requirements are significant, but it's the ability to manage the data across the environment, I think, becomes absolutely critical. And I think that's what's interesting about the Hammerspace solution, is that we're not talking about storage management, we're talking about data management, data orchestration, right? That's the thing that organizations really care about from multiple vantage points, not just from a performance, availability, protection, but also from a governance, compliance, security point of view. There are lots of things to bring together here, and I think Hammerspace covers off a lot of these capabilities in a fairly elegant way. Excellent.
Molly, anything to add there?
I think we're good. I kind of covered my thoughts on that earlier.
Excellent, thank you. I know I also, since I think Roxanne asked that question, I'll do a quick shout out. There was a great I think Roxanne made the point at the All In Summit that it's also not just AI, it's the convergence of a number of technologies: AI, robotics, biotech, things like
Right.
CRISPR, blockchain. I mean, all of these things are converging and driving massive data growth. So I think there was a question about data management policies and solving for data sovereignty issues like GDPR, CCPA. Molly, I think you did touch on that, but basically just using Hammerspace uh, policies that we call objectives, you can ensure that certain data sets don't move to the cloud or don't move. I think you touched on that. Anything else you'd add there?
I would just add that sovereignty is, you can't, open a web browser without hearing something about sovereignty right now. And it's a really big deal. And I think as organizations are looking at how do I architect my sovereign AI, my sovereign cloud, whatever it is that you're focusing on, it's a really big deal to think about, do I need to do this physically have a system where all the data goes and I secure it, keep it sovereign because of the actual physical system that it's in? Or can I do this more logically through software that can be audited, tracked, know who has accessed which data, where it went, and which would you prefer as an organization? And granted, this is very much a conversation that we'd love to have with folks thinking about this. But there's a lot of risk when you think about I accomplish my security or sovereignty or government, security by being in a physical system, but that data then has to be used elsewhere. So you have users copying the data, maybe to their local machines, then placing it somewhere else. All of a sudden, you lose track of where your data is going. And in AI in particular, the data that existed before doesn't have a one-to-one relationship with the app that created it. Now others are wanting to use it and get access to it. So being able to see what happens with it and control that and also report on it across systems is becoming increasingly in vogue and something to consider for sure.
Okay, and then let's kind of close with this. It's a little bit of a two-part question. I think it's related. So the first part is, will AI users want aggregated access to various SaaS silos? How is that done? And then the second part is kind of, what's the relative advantage of staying in today's siloed architecture, versus going to kind of this new architecture, something like what Hammerspace provides. So I think the answer to the first question is yes, but maybe Simon first and then Molly, or I'll just let you both comment on this. Will AI want access to all this siloed data in various SaaS platforms? And then, what advantages do you see to staying with kind of the traditional, I'll say, a storage-centric architecture versus more of this data-centric that we've been talking about? So open it up to you both.
Yeah, I mean, I think, if we look at things like agentic, where those kind of capabilities initially looking to be deployed are very, very, a lot of innovation is coming out of the SaaS platforms. So kind of automating, a lot of those capabilities. So I think absolutely is the answer in terms of providing access to that data. The benefits of staying of kind of doing what you've always done. I mean, that's the easiest perhaps thing to do, but I think ultimately, you are going to end up throwing kind of more hardware at the problem,
Yes.
and that's going to have a cost. And I think in this environment, that cost is going to rack up pretty quickly. So I think, I think that's the challenge, right? You can go all in on a single platform or a small number of platforms. You can consolidate, right? But there is going to be a cost to that as well.
I think well
the
said.
only thing I think I'd add to that is, it's not just about hardware cost, but it is about people efficiency, the human workforce as well, that it can get quite onerous managing, copying, tracking data, getting IT tickets open to move data to some other app. Like, that's pretty cumbersome. So there's definitely a human efficiency piece here I think we can consider. as we think about this type of more unified logical architecture, automating data management, that type of thing that we shouldn't forget about as well.
Excellent.
And Eric, I do want to touch on one other question. I know we're really tight or kind of running out of time, but there was a question about the idea of, is this like software defined memory, you know, kind of a data version of that.
Oh, yeah.
An analogy we often use is, all of us, I'm sure, are familiar with server virtualization. That was a way to get great efficiency out of your server environment with VMware and things like that. There are network virtualization tools now and products. The idea of using software to optimize your memory and your data is absolutely a reasonable concept to think about here, that by using software, you can get as much you can use your data or your infrastructure the way you want to, maybe over provision it a bit. There's different tactics you can take here. So I think that's a reasonable way kind of to abstractly think about what we're doing here. But it is something that people do tend to think about, is virtualizing above your infrastructure so you can optimize, is something that Hammerspace is doing, that has been done in other parts of the industry, servers, networks. Now we're doing it with storage. Of course, you could do that with memory with some of the technologies out there. So yeah, I think that's a reasonable observation.
Excellent. Well, Simon, thank you for joining us. This was great. Really appreciated it. Great discussion. And Molly, as always, thank you for joining us and for both of you sharing your insights. To everybody out there, thank you. And we will be sharing the recording out. So if you'd like to share it with any of your peers or anything, please do. So thank you and have a great rest of your day.
Thanks for joining.
Thanks all.